Well, hello everyone. This is Ala Hassan, and I'm pleased to give a response on this question posted on the A-level sub on Reddit. Right now, this is a question about isomerism, about geometric isomerism, the EZ isomers. Now, I'll explain what EZ isomers in a bit now, and we give in for molecules. So, really, in this basic question explanation, I'll try to go through skeletal formula, how we can sketch formulae for molecules, and then see how we can basically decide if they have easy isomers or not. Now, let's start with molecule A. I have 2-chloro-4-ethyl Higgs 3-ene. Now, what does that mean? Well, let's break it down. Let's start with the backbone. The backbone here is that Higgsiene, which means that I have 6 carbons in the back chain because of the hex part, and there's a double bond on the 3rd carbon. So I'm going to start with doing the nodes on a zigzag, okay? So I have a first node here going up, then going down. That's the 2nd carbon, that's the 3rd carbon. Going up, that's the 4th carbon. Going down, that's 1, 2, 3, 4, 5th, and that will be the 6th carbon. Okay. Now, of course, once you get the hang of it, you don't need to write the nodes. I'm just doing that to guide you and also help me from falling into confusion. Okay. So that's 4, that's 5, that's 6. Okay, that's a 5. Good. So now, where is the double bond? Well, double bond is at 3, 3, and 4. So let me put the double bond. So the double bond is here. This is for part A. Now, is that it? No, I do have some side groups. On the 2nd one, I have a chloro. So let me just put the chloro in a different color on the 2nd one. Okay. So here I have a chloro like that. All right. That's chlorine. Okay. All right. And then on the 4, I should have an ethyl group. Now, ethyl, let me put a circle there. An ethyl here. Ethyl basically is 2 sticks. An ethyl is basically like ethane, but without a hydrogen. Okay, so if you have the methyl, the alkyl groups, the alkyls side groups, just to help you out, side groups. Okay, so if I have methane, okay, methane is CH4, so methyl would be 4 minus 1, which is CH3. So not CH4. We know alkane, ethane is C2H6. So the alkyl or the ethyl is simply C2H5, 1 hydrogen less. Now, this is one way of putting those groups. Another way of putting those groups, the alkyl groups, is by starting with CH3, and then each step we add CH2. So we'll go like this, okay? For the ethyl, we have a CH3, but then because it's 2 carbons, the next one would basically have, the next one would have CH2, so that will be CH2. Okay, of course, then you can guess for the propyl, what we have CH3, and then CH2, CH2 for 3 carbons. And of course, then the butyl alkyl will be CH3 for the first one. 2nd, 3rd, and 4th will be CH2 4 times. Okay, now, of course, if you're doing skeletal formulae, that basically means a stick. Okay, so that's just a stick. That's just 2 sticks. That's 3 sticks. That's 4 sticks. So here I'm going to put 2 sticks. So that will be like that, the node, of course. Okay. Now, of course, if I put it like that, it will be a line. Maybe you want to change the angle a little bit. But anyway, it doesn't matter. You get that. All right. Good. Now, when we do EZ kind of isomerism, we need to focus on the double bond. And we make the double bond our center stage. So let me highlight that on the screen. So this is my double bond. Okay, here. That is my center stage. And let me ask, is there a way of rearranging that in a different way? Well, okay, fair enough. If you focus here more, you would find that I should have, here I have 3 sticks on carbon number 3. So I should have really a hydrogen there, right? So let me just indicate that hydrogen. I should have a hydrogen here, right? So that will be 4 sticks. There's a hydrogen here. Okay, so if I want to just to redraw this again, I'd have a double bond like that, and then I'd have here the alkyl. Okay, I can just put like a alkyl 2 sticks, and here I have the backbone chain, which is like that. So it's another ethyl group. So I have 2 ethyl groups. okay, here 2 ethyl groups. And then on the other side, I have the one, which is the H here. Okay. One is the H here. Okay, fine, fair enough. And the other one is the carbon. Okay. So one is the H, one is the carbon, 2 and 1. This is 1 and 2. And that will be, of course, the 3. Okay. That's an H, which is the green one. Let me just change that color so we can be consistent with the coloring. Okay. And let me just continue with the numbering. So that's the 3, that's the 4, and that will be 5 and 6. Now, if you notice on the right-hand side, those two are the same, right? They are just 2 carbons, right? 2 carbons. So flipping them, changing them will not change isomerism, okay? That's exactly the same. So for this one, I can't have geometric isomerism because like it's always, yeah, this one and that one, but those two, changing them will not make a difference, okay? So I can rule out A. A, of course, is not the case. So again, let's do the same steps with sketching the molecule for the second one and see whether we get some isomerism or not. Okay, so let's start again. I have a hex 2-ene this time. So again, let's just do the nodes. 1, 2, 3, 4, 5, and 6. And I have a double bond on the second carbon, so second to third. That's my double bond. Okay, of course, that's the case. And then what do I have? On the 2, I have a methyl. If you look here, on the 2, I have a methyl. So that's a stick. Remember, the methyl is just a single stick, or CH3. Remember, that's a carbon here. I have a carbon, and then I have 3 hydrogens, okay? So that's your methyl on the second one. And the chloro is on the third one. So the chloro will be here, chloro, okay? Now, again, that should be an easy one. If we focus on the center, on the double bond as a center, I can see that those two are identical, okay? They're the same side chain. So really just, I can't have isomerism because both of them are the same side. Switching them does not make any difference to that molecule, okay? So definitely not B, all right? So let's see if we can do a third one, okay? Again, I have a hex 2-ene, okay? So I'm gonna do the same process again. I'm gonna do the 6 carbons. So here 1, 2, 3, 4, 5, and 6. Now I have a 2-ene here for the C part. So I have a double bond from 2 to 3. Okay. And then I have a dimethyl. So I have 2 methyl groups, 1 on 2 and 1 on 3. So let me put that with the red stick for the methyl groups. So on 2, I should have a stick here, and on 3, I should have a stick here. Now, if you look again on the second one, if we make the double bond the center stage, that's the double bond, the side groups here are exactly the same, just like one single sticks, okay? So again, here, I don't have isomerism here, the geometric isomerism, so definitely ruling out C. Now, let's do the same thing now for the last one, okay? I'm just gonna take a shortcut. I'm gonna remove the double bond here. Of course, I have 6 carbons there, and the double bond this time is the third one, okay? So let me just do the third and fourth. That's my double bond. And I have 2 and 5. I have a stick, okay? So here I have a stick, which is the, oh, that's a chlorine, okay? So let me just green for the chlorine instead of the methyl, okay? So here, that's the chloro. Here, okay, on the second one, or on the fifth one as well. Okay. Now, if you notice here, I should have hydrogens here and here, okay? I should have a hydrogen here, and that stick, and here I have a hydrogen, right? Ah, so there's 2 ways to switch. I can switch them, right? If you look at this one, okay, the big chain, of course, is that bit. And then I have a double bond, which is my center stage, and then I have that one on the other side, okay? If you put like a center line, imaginary line here, the big groups are going across. And if it's across, it's an E isomerism, right? This is an E isomerism, okay? Is there any other way of doing it? Yes, I can switch this side or the other side, okay? Yeah, I can, let me just use a high, I can, here I have a H and the side stick, the blue one, I can switch them, right? I can put the hydrogen on the bottom and put the blue stick on the bottom, and then I'll have the big groups on this side. So 2,5-dichlorohexa-3-ene, or answer D is the answer that gives me easy isomerism. So this is the molecule. Okay, and again, let me just show you the Z that when they're both the same side. I'll show you how the Z will look like. Basically, I'll remove the H, and I will remove that part, the 4 and the 5. Okay, and therefore I'll put the 4 and the 5 on the other side. So here I'd have, oops, that's just, I don't know, the size. Yep, sorry, beg your pardon. Anyway, so that's the 5 and the 6. Okay, and then the hydrogen, of course, will be here. So if you notice here, okay, I have the side groups on the same side. That will be the Z. Now, not will be the E, it will be the Z side. Now, I hope that will be clear. I hope you enjoyed this this explanation. By all means, if you need further clarifications or you have more questions, by all means, post them on Reddit's A-level sub, and I'll be happy to answer them. All the best. Thank you very much. And this was Mr. Ishaq.